Hello, welcome back. This is the second example in which we have to find out moment of inertia about x-axis. So basically, area. This is the area, and it is having a curve, and the equation of curve in terms of y of fx is given here. Y square is equals to 400x is the equation of this curve, and this dimension is 200 mm and this dimension is 100 mm. We have to find out moment of inertia of this area about x-axis, which means this axis we will consider as 0 0. So this is our 0 0 axis. Now as we have to find out moment of inertia about x-axis, so our first step is to to consider a differential strip which will be parallel to the axis about which we have to find out moment of inertia. So that is axis x-axis. So this time we will have a elemental strip. Say this is the elemental strip which is cutting the curve uh, at this point, this arbitrary point, and I'm writing. The coordinate of this point say x, y. So this distance is x. Sorry, this distance is 100. So if I consider, this value is x, and this value is y. So the width of this strip will be 100 minus x. So this is our strip, and the thickness of the strip will be, say, dy. Okay, so this is y, this is dy, and this is 100 minus x. So the area of this strip will be dA, and dA can be written as you can see, this is a rectangular strip which is having a differential thickness. So we can write the area of this dA as 100 minus x multiplied by dy. So dy is the thickness multiplied by the width or length of the strip. So the length of strip is 100 minus x because this value is x, and 100 minus x is this one. Okay, so that is the thing that we are supposed to do here. Now dA is found. So again, finding the moment of inertia about x-axis. So writing here, and the equation there becomes, now you can see this is the 0 0, and the maximum value from the x-axis is 200. So the limit here will be 0 to 200 y, and this is the y value, say y dash. So the y dash into dA. So that is our condition. Now again, further solving it, we have y dash into dA. We will put the value of dA this here. So this becomes 100 minus x into dy. Now further, what we will do is 0 to 200 and y 100 minus, now the value of x can be written from this equation because the equation of curve is given, which is y square is equals to 400x, or we can say x is equals to y square by 400. So this value can be written here in place of x, so which is y square by 400 into dy. So we have to solve this integral. So I have written here, but I have also provided the solution, and the solution here is to first choose the differential thickness and the area of differential thickness and the element. So the limit here is 0 to 200 mm. So Ixx is y square to dA. Now dA is 100 minus x into dy. Now we have reached here. Now further solving it, what we can do is uh, we can further solve it. 200, and this becomes 100 y square minus y to the power 4 by 400 dy. So we can write this as 100 y cube by 3 minus y to the power 4, sorry, y to the power 5 into 4000 into 5, and the limit is 0 to 200. So we have to solve this equation to get the value of ixx. So again, if I write the value here, so this will be considered as like this: 100 into 200 cube by 3 minus 200 to the power 5 by 2000. So solving this, we will get the value as this one. So this is the value of moment of inertia: 107 into 10 raised to power 6 mm to the power 4. So that is the value of moment of inertia about x-axis of this area. So this is how we find out moment of inertia using the integration. So in the next part, we will discuss now about the composite areas.